Hi. Wow, this place is gorgeous. I've been spending almost all day just staring off into nothingness and contemplating life. Feels very deep. I'm Charity, and I'm here to talk about observability. Do most of you identify as software engineers? Any more operations-y types? Of course, my posse up here in front. What else? Anybody here who is not a software engineer or an SRE type? No? All right, cool. Just curious. Well, I'm going to tell one of our great founding myths, creation myths, just to catch us up with where we're at. It starts with Adam and Eve, I guess. In the beginning, there were users and people who wrote software for users. When it broke, we debugged it, often in production. But these were the original software owners, right? Had a really tight feedback loop of you build it, you break it, you fix it. Now, this obviously had some problems. It lacked some safeguards. Operations was very labor intensive. Software gets more complicated, blah, blah, blah. The internet became a real thing that made people money, so we had to keep it up. So we brought some processes, right? And we started to specialize, and there became developers and operations specialties, and, there build pipelines and staging environments, and all of these things emerged to try and make software development safer, more robust, more resilient. And then I'm not really sure where my metaphor is going here with the apple, but if we take a step back, this is a story about software ownership. And then the DevOps movement came along, and we were like, hey, we now have completely different people developing the software versus understanding it and debugging it and maintaining it. This doesn't work very well. And so we've been trying to knit them back together to kind of get back to that original state of glorious software ownership. And if you think about what ownership means, I've thought about this a lot. And I think it means you write it, you deploy it, you debug it. The same person. Not all 100% of the time, but you have to have the ability and at least sometimes do it, right? So if you're an ops person who never develops software, but only deploys and debugs it, you're not really a software owner. And if you're only a software engineer who only writes software and never deploys it and debugs it, you're not really an owner. If you don't have the permissions to deploy it, you don't have one of the necessary ingredients to be a software owner. Why does this matter? Because we've learned so much about what makes software great, what makes it friendly to the people who are creating it, who want work-life balance, and it is closing the feedback loop, making it so that the person who is writing the code is best positioned, deploying it, watching as it goes out, catching the errors quickly before the users do. And DevOps is kind of like Jesus, I guess, in this metaphor. The New Testament, who came to bring the gospel. I don't know. Let's leave that behind. Thou shalt own thy software in prod. You can see my T-shirt. Says I test in prod, and that requires observability. So when I say observability, now some people will use this word kind of as a generic synonym for telemetry or monitoring. And that's not a sin, because I'm not God. If I was, it would be. I use it in a very technical sense, a very specific sense, which we're going to talk about in this talk. But first, let me introduce myself so you know what my biases are and where I'm coming from. My name is Charity. I've been on call since I was 17. I co-wrote Database Reliability Engineering. If you have a copy of this book and you would like a unicorn sticker to fix the cover, see me after class. I started a company 2.5 years ago called Honeycomb. But I've spent most of my career, you can tell I'm from ops because this is how I feel about software. The only good diff is a red diff. But I've spent most of my career, the position that I really love is being the first infrastructure hire that gets hired when the software is brand new and they've just started to find product market fit and they're like, oh, holy shit, we have something here. And then I come in and I make it real. I take their duct tape and I deploy more elaborate and redundant duct tape. But I love that spot, right? I've done this repeatedly. I did it at Linden Lab, on Second Life. I did it at Parse, like pre-beta, way before the Facebook acquisition. I love that. And then I started this company based very directly off of my experiences with Parse during the Facebook acquisition. But it is also important to note that I, despite being an operations engineer for over half my life, really don't like monitoring. Sorry, it's very important. You should totally do it. And Honeycomb is not a monitoring company. I have very strong opinions, specific opinions about where the industry is going and where it needs to go, which definitely informed like the company that Christine and I created. So sometimes I will be accused of I'll be like, this is what needs to be done. People will go, yeah, you're just listing all the things that Honeycomb does. I'm like, I know. That's why we did them. But, I am a vendor. So I engage in motivated reasoning sometimes despite my best efforts. So take that with a grain of salt. Disclaimer done. So my thesis, the thesis of this talk. So as an engineer and as an engineering manager, I have seen organizations, I've driven change at organizations where they try to put software engineers on call or make them responsible for their code. And they do this because they know that it makes software better. Some of these efforts have succeeded. Some of them have failed. Some of them have failed gloriously. Some of them have failed and then succeeded at the same company with the same people, more or less, wanting the same things. And what I realized, looking back over my career, is that the difference between failure and success comes down to observability, a gap in what is possible, and the types of observability that is available. And it's important to note here that I have the great fortune of always having worked on more or less functional teams. So these have never become tire fires due to like one asshole or some manager or whatever. Like that can totally happen too. In my case, we've always been pretty functional. So all of the catastrophes have been technical. It's a blessed life. So what is observability in this context? So control theory, if you just Google it, you see that the term comes from control theory. And it says that it's a measure of how well internal states of a system can be inferred by knowledge of its external outputs. And if you think about how this applies to software, it seems pretty obvious that it means, can you understand your software, your systems, the code you're writing, the insides, just from asking questions via your tools on the outside, not SSHing in and running strace or netstat or GDB, but can you debug your code and its behavior just using the outputs? And specifically, can you answer new questions without having to ship new code, right? This speaks to the level of abstraction of like you were talking about, of the information that you're gathering, right? Is it at the right level so that you can use them as building blocks and construct brand new questions to address new scenarios that you've never seen before? Or do you have to go, weren't capturing that, and ship new code or ship a new question? You have an observable system when your team can ask any question, track down any unknown behavior in a pretty reasonable amount of time without having predicted it or shipped any instrumentation specifically for that. We learned this the hard way at Parse. Parse is a mobile backend as a service, or it was. Facebook shut it down. I'm definitely not bitter about that. But it was glorious for the users. Like, it was so flexible. You could write any query you wanted and just upload it, and we had to just make it work on MongoDB without affecting anyone else's queries. You could write any JavaScript you wanted and just upload it to us. We just had to make it work without affecting anyone else. It was great for users. Never do this. It's a terrible idea. We had some of the best engineers in the world, and yet around the time that we were getting acquired by Facebook, I was coming to the appalled conclusion that we had built a system that was basically undebuggable by great engineers doing all of the right things. Scar tissue, sorry. we had all this monitoring stuff. I tried everything. Finally, we got a handle on our problems by shipping some of our data sets into Facebook's Scuba tool, which is this tool that they hacked together overnight 10 years ago to deal with their MySQL problems. And it's aggressively hostile to users. It hates you. It really wants you to go away. Does one thing well, which is slicing and dicing on dimensions of arbitrary cardinality in real time. And I realized that long afterwards that this was the difference between monitoring, which we were doing, that allowed us to find and resolve questions that we'd already seen before, and observability, which let us ask questions about things we were seeing for the first time. A thing that I realized just recently is it's a perspective shift, right? Monitoring has always been about one piece of software sitting over here watching another piece of software. Like, how you doing? Are you doing this? Here's a threshold. Are you hitting it? Right? It's always been a third-person perspective. Whereas observability is about winnowing its way into the heart of your software and explaining itself back to you, right? It's a very first-person perspective. I just think that's interesting. But like monitoring, like it's me sitting over here going, what's the capacity like? Do I need to provision more? And observability is sitting on the inside. It doesn't even know about what the capacity is available. It's a request that is trying to execute. And the question that's coming in is, why are we getting complaints about users seeing the wrong thing? And so you consult your observability too. I'm going down a rabbit hole. I'm going to keep going. This roughly correlates to known unknowns versus unknown unknowns. And when I think about why, as an industry, we have had a hard time putting software engineers on call, well, A, there's masochism. Ops has a terrible track record of masochism. That's on us. But B, there's the tools that we've been giving software engineers to try and help them explain their code and the reports that they're getting. And all of these tools that we've been giving them are monitoring tools. And you can have a very experienced senior software engineer who has, this report, from a user that things are failing. And we give them dashboards full of things like load averages and memory percentiles and free versus used memory. And you just see them kind of going, what? Totally reasonable. It's speaking the language of systems and aggregate, where software engineers need the language of unique events from the code's perspective, right? You put that same software engineer in front of a tool that lets them explore, and what you're seeing is variable names that you just wrote, right? You're seeing the things that orient you as to the system that you're working in, and it's very different. So the entire industry is kind of experiencing a lot of shift and churn around this question, which is why a couple of years ago, Greg made this amazing slide. He didn't even propose an answer. He just was like, monitoring's dead. Let me tell you all the ways that monitoring's failed. And I, of course, enthusiastically agreed, but always would have. He said it's dead because monitoring systems have not fundamentally changed in 20 years. While the ways that we build systems have revolutionized several times over, many times over. How old is Agile? Is Agile even 15, 20 years old? I don't fucking know. It's ancient, though. Like, we have so many different generations of architectures and infrastructure, and yet we're still writing Nagios checks. So this is how he defines monitoring. I think it's a great definition. It's the action of observing and checking the behavior and outputs of a system and its components over time. This manifestly does not work for distributed systems or systems of any complexity. And complexity is what it comes down to, because it's going up a lot. I'm a music major, by the way. I'm not really a computer scientist. So when I tried to graph this for you, I just kind of drew a line. It's going up. You're welcome. Let's look at some architecture diagrams, though. Like, there's a lamp stack. Most of you here are about my age or so, and so you remember the humble lamp stack. You got to choose between MySQL versus Postgres, the database. And you get to choose between PHP or Python or Perl, right? Perfectly respectable website. Runs most of the systems in the world still. But here's an architecture diagram of parse a couple years ago. And that blob in the middle is a few hundred MongoDB replica sets running arbitrary queries from developers all over the world. There's another blob in there that's like all the JavaScript. It's not as easy to reason about, to put it simply, and yet it's getting better. Worse, whatever. There's the national electrical grid of my country. And this is increasingly what our systems are looking like. And this is the model we need to have in our heads. It's not the flow that we can keep in our heads and reason about. It's this. There are some problems that you will only see at a very hyper-local level. A tree falls over on Main Street in the middle of Iowa. Are you going to predict that? Nope. But you do need to be able to accurately diagnose where the fault came from, because half of Iowa is missing its power, right? And there are some problems that you can only see when you zoom way out and look at patterns. Like if, let's say that all the bolts that were manufactured in 1983 are going to fail twice as fast as all the other bolts, causing, a bunch of outages that look sort of unconnected, but they are connected by something, which is an outlier and some data that you have in a spreadsheet somewhere. I don't know. Some problems are hyperlocal. Some are the opposite of that, whatever that is. Global. Thank you. So helpful. The shift in our perspective basically has to parallel that. And we have to be shifting what we're looking at from a world where we can predict most mistakes, where most problems are known unknowns, to a world where they're so unpredictable that you really just kind of have to give up the illusion of control and embrace it and think about resilience rather than preventing failures. Or, as I tell my engineers all the time, you're not bad at debugging. You just have shitty tools. So, here are the big technical trends, right? What it comes down to is, welcome to distributed systems. You are all distributed systems engineers now, or in the near future. It's probably fine. But the lesson number one of distributed systems is your system is never actually up. It's never actually working completely. Many catastrophic states exist right now that you don't know about, and probably some that you do know about or suspect. I hear some laughter as of realization and recognizing. But that good feeling that you get when you look at your dashboard and you're like, it's all working today. That's a big lie. And it's a lie that turns toxic with distributed systems if you start to believe it. Because distributed system, it used to be that most of the times that we got paged, it'd be like, oh, yep, that again. Well, our teams are getting better, and so we've automated or remediated most of those out of existence. Now when you get paged, every time it should be, I wonder what that is, right? Because if you knew what it was, you would have fixed it. Instead, we get this infinitely long list of almost impossible things that almost never happen, except for once or twice they do, when combined with other impossible things. Which, side note, makes staging environments basically useless. May I repeat? Which is why part of this whole releasing control and embracing the future is so many engineering teams that I have been on, that I have seen, spend so much time trying to make staging work perfectly or resemble production well enough. It's a black hole. You can put an infinite amount of time in there because it can never be achieved because it is not production. There are always going to be some delta that you are shipping to production. It is the only time that change set will ever be applied to that, point in time state of the infrastructure with that deploy code in that environment. There's some things that are untestable because that combination is unique. And there are many more things that are just not worth your time to track down in staging. Instead, since we all have limited engineering cycles, we need to take some of that effort away from staging and put it making guardrails for production, making it more resilient, making it harder to ship failures successfully, making it easier to detect failures quickly, making it so that users never have to see failures. with things like feature flags and canaries and promoted releases and blah 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 blah. Whatever. What I hate about I don't always test my code, but when I do, I test in production. What I hate about that meme is that it implies you can only do one of the two. Well, you can do both. And most dumb failures will be caught by dumb tests. You should absolutely write your dumb tests. Do it. I mean, your wonderful tests. Write some tests, but don't feel like they're going to save you from failure, because they won't. So don't forget about production. Anyway, back to the point. Observability turns out to be a missing link. It is one of the reasons that we have been so late to embrace testing in production. Because right now, we all kind of ship code and wait to get paged, which is insane and terrifying. What if we had the kind of observability where we could trivially just watch the change go out, like muscle memory? My change is going out. Did it do what I expected it to do? Does anything else look weird? If we did that, we would catch 80% of problems before users ever could. But we haven't. Why? Well, because the same technical nuts and bolts that you need to achieve observability for putting software engineers on call are basically the same things that we haven't had for the last 20 years. It's kind of pivotal for all of these things. So I feel like at this point we've been very abstract. So let's look at some examples of the kinds of problems that we had in a LAMP stack versus the kinds of problems we have with distributed systems. Anyone who's ever done anything in production here has probably debugged some version of this problem. Photos are loading slowly for some people. Why? So here are some common answers to that question for the past many years. The database is getting starved of connections. Whatever. Pretty obvious. You can monitor for these things. Characteristics of this type of environment. It's very friendly to intuition. Dashboards are great. You can view the health of the system at a glance. The health of the system more or less accurately represents the experience of the user. Since all of the pools are shared, if your uptime is 99.9%, then roughly 1/10 of the time, someone's getting an error. And it's distributed across all your users, so nobody really notices. Best practices, every alert must be actionable, blah, blah, blah. Runbooks. So now let's look at this question, and these are actual outages that were taken from Instagram and Parse. You guys read that? Not sure what I'm supposed to monitor for here. I've got more. This is that infinitely long tail of things that almost never happen. I can go all day, dude. That one was one of my favorites, where they come to me one day and they're like, "Push is down." I'm like, "No, it's not. I'm getting pushes, and the push is in a queue, so clearly push is not down." They're very insistent. They come back the next day and they're like, "Push is still down. We're getting so many complaints." Finally went and tracked it down, and it was Android devices at least used to need to keep a persistent connection open to receive messages over a channel. So we kept all of our Android push notification servers in an auto-scaling group, and one day we increased the capacity, as you do, and the increased numbers of hosts in the DNS record made it overflow the UDP packet size. Fine. Usually it just fails over and retries from TCP, right? Which it did successfully for everyone in the world, except some people coming from a router in Eastern Europe. So clearly the answer here is to monitor every router in the world, right, for UDP fail over to TCP correctly, right? No, you just can't monitor for this shit. You can't, you shouldn't try. These are all unknown unknowns that may have never happened before, may not ever happen again, not worth your time to go through the part of the postmortem where you guys are like, okay, so what are the monitoring checks we're going to add, and what is the dashboard we're going to make so that we can find this problem immediately the next time? It's just not a good use of your time. What is a good use of your time is taking that amount of time and investing it into making your systems more debuggable, more explorable, and the rest of the stuff we're going to talk about. Characteristics of these systems. many components. Hard to reason about in your head. Shouldn't really try. You need to take it out of your head and put it into a tool where you and your team can do things with it. The hardest problem is often figuring out which component the problem is actually coming from, because after it originates somewhere, it bounces around, touches everything. And the health of the system is almost irrelevant. Like if you're in AWS and you've distributed your load across 3 AZs and one goes down, should you notice? No, you should never wake up. From the perspective of your code, nothing happened. Everything's fine. Your system is 1/3 down, but your code thinks everything's fine. That's great. Software engineers should never get woken up for an infra problem. But conversely, you might have an uptime of 99.9%, and yet the shard that serves users with the last name that starts with STI is 100% down. And so 100% of requests are failing for a large enough that you should care number of your users, right? Because now that we've distributed, we've partitioned and we've blah, 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 blah. We've created all these little spots where a small thing can go down, but is 100% of the thing to some people. It's just a different way of thinking about things. A lot of what we do as engineers consists of picking things up from the unknown stack and trying to put it in the unknown stack, where it can stop being an engineering problem and start being a support problem. We're just kind of shifting around who does what work and where, but it means that we need different tooling. So the rest of my talk is going to be about what specifically that tooling must have. It must be instrumentation first. It must support high cardinality, high dimensionality. It must be event-oriented, structured data, owned, sampled, and tested in prod. What problems? How are they different? Well, instrumentation, this could be an entire day-long talk in and of itself. But it's about, like, the place to start is always at the network hop, right? Anytime that a request is hopping the network, you want to instrument and store what that request was and how long it took. Because then at the very least, you can follow breadcrumbs and find out where the source of the problem that you're investigating is. And then you can always attach your GDB or whatever. I will get in an arm wrestle about metrics. I hate metrics. It's so worthless. I prefer events for reasons. When I talk about cardinality, imagine you have like a collection of 100 million users. The highest cardinality will always be any unique ID, UUIDs or unique request IDs. Slightly less, but still high, would be first name, last name. Very low, gender, and I assume species is like 1, right? So what of these data types are the most useful to you when debugging? It's all the high cardinality stuff, right? It is all high cardinality. How is species equals human supposed to help me when I'm debugging a problem for AWS users? It's not. It's not going to help me at all. And yet, metrics have historically been very, very bad at handling high cardinality. And in fact, if you Google it, it tries to give you a lot of advice about how not to have these problems and how to get things done with just low cardinality values. I am excited that newer data stores are, I think by adding key value pairs and structured data around the tags, addressing this. Super stoked about that. This is not optional. This is the first question you should ask, is what are the cardinality limitations of any solution that you're starting to explore? It's not a nice to have. At Parse, the thing that made the difference for us when we got onto Scuba was nothing more than the ability to break down. So say Disney comes to me and is like, Parse is down. I'm like, Parse is not down. Like, behold my wall of dashboards. Like, they're all green. Because like they're doing 4 requests per second, and I'm doing 100,000 requests per second. And if we're doing time series like aggregates, that's never going to show up in my graphs. Literally never, right? So Disney's like, Parse is down. Well, I have to care. So I would go and start, it could be literally anything, right? And the thing that made it a tractable problem was the ability to break down by Disney's user ID and then every combination of anything else, right? So Disney's user ID and then, break down by endpoint and latency percentile and raw queries. And just that ability alone to ask a specific question makes impossible problems trivial. So, structured data. I also have a beef with anything that does read-time aggregation, because if you think about it, aggregation is nothing other than predicting what kind of information you're going to need in the future and aggregating on it. You need the access to those raw requests. You want to be doing aggregation at write time for anything that involves debugging what's happening now. I like events because events tell stories. The thing that you were mentioning about Prometheus not having a point in time, this is what it looked like, is another manifestation of this problem. You could always derive aggregates and metrics from events, but you can never do the reverse. You can never go back to the event when all you have is the metric. Because metrics have discarded all of that context, all of it, for good, and then selectively re-added some back as tags. With the event, so you're saying you have 300 metrics. So for us, that would look like one event with 300 pieces of context, right? And the powerful thing about that is you're saying all these things were true at once for this event. And that, when you're trying to hunt down outliers, that is what you want. You want to be able to go, instead of going, I see a spike in this, IPv4, Q metric over here, and it looks like this thing over here someone had a problem around the same time, right? That's the best you can do when you've discarded all of the context, all of the connective tissue for those values. I get all ranty about this. Arbitrarily wide events are what you want because that allows you to knit together as much context as possible. And that's what you need for detecting these outliers. Dashboards, I think that most of them should die in a fire. I say this with extreme prejudice. A couple are fine. Interactive dashboards, I got no beef with those. But dashboards, the model just flipping through dashboards looking for spikes, that's not science. That's not debugging. That is not engineering. That is eye exercises. It's not telling you shit. It's sending you off on lots of red herrings and wild goose chases. It's not telling you anything. In order for it to be engineering and science, you need to formulate a question, a hypothesis in your brain. I wonder if it's doing that, and go look for that. And then, based on the answer, formulate another question, and so on and so forth, so that you're following the breadcrumbs. And it's a mystery to me that we haven't had this in engineering, because they've had it in BI this whole time. They've had nice things. Can you imagine a BI analyst who's just user behavioral question. Let me go sift through all of my dashboards to see which scenario this looks like. No, that would be insane. No, they ask a question, and then they ask another question, and they follow the breadcrumbs until they figure out exactly what that user did, exactly why they were doing it. And we need the same approach to our events. We need to ask exactly why that failure happened, and what connected these half dozen failures. What did they have in common? Dashboards are such a common part of the postmortem process because they are the illusion of control, right? When you have the perfect dashboard that describes exactly what you're doing, it's just magic. Yes, we didn't have to waste 2 hours tracking this down because we found it immediately. So in the postmortem, we're like, what dashboard can we create so we can solve this problem exactly the next time? Okay, cool. Now, fast forward by a year, how many fucking dashboards do you have? And because you're not asking a question and knowing what you expect to see, when a source just stops sending its data and the line isn't there that would have had the spike, you're fucking blind to it. It can take you hours to realize what should be there but isn't. Sorry, too much of my youth spent staring at dashboards. Every dashboard is just an artifact of some past failure. Liz likes to call it, she says that dashboards are technical debt, and I completely agree. They jump to the answer without starting with the question, and you don't know what you don't know. The question is the entire point, right? I remember back at Parse where I had all these great tools to give me answers to questions, and they did that very, very well. But I didn't have questions. I had vague symptoms and feelings and reports that may or may not be reliable. And I wasn't trying to figure out what the answer was, I was trying to figure out what the question was. By the time I had the question, I pretty much knew the answer. Like, all of the work goes into figuring out what the question is. Like I said, I got no beef with dashboards that let you drill down, that let you, and what about this? And drill down, but most of them just don't, so. And raw requests. You have to be able to get back to the source of truth. Like, remember how we defined observability as the ability to ask new questions without shipping new code? Aggregation is code, right? It is a way that you have tried to munge or manipulate the data before you got to see it. In order to ask a new question, you have to be able to perform operations on those raw requests. And yes, it is cost prohibitive to store them, certainly to store them for a long period of time, which is why you should probably sample. And you should probably discard them and aggregate them after a while. And all of this sounds like hard work, and it can be, or expensive, and it can be. Yes, I charge a lot of money. And the key there is, if you don't need it, don't do it. If you have problems that are mostly known unknowns, if you can solve your problem with a LAMP step, for God's sake, do that. Do not inflict upon yourself the problems of distributed systems if you don't have to. The point is, for more and more of us, we can't avoid it. So, aggregation is a one-way trip. Smooshing that data that happened over an interval into a single value destroys your ability to ask new questions about what happened in that interval forever. I guess I do go on about this at some length, don't I? The point is, you can't hunt for needles in the haystack if your tools do not handle extreme outliers. Black swans are the norm. So some examples of questions that are more like explorations that this kind of tooling, not just Honeycomb, but like the cutting edge of tooling allows you to do are like these. And these aren't like true, false, up, down. It's more like, what is the behavior? In a lot of ways, I feel like we're starting to get back, to claw back so many of the debugging tools and techniques that we lost when the monolith got broken up, right? We're starting to gather them all back so that we can answer the same questions that we used to be able to. But the point is, users don't care, actually, what the health of the system is in aggregate. They don't care about how much reserve capacity you have. They don't care about any of those things. What your users care about is their experience. And what that translates into, for us as engineers who are writing and supporting these systems, is the ability to introspect what's happening at the event level. Like from the minute it enters our system until the minute they receive the answer. Like, what was the behavior? What was happening? Why did it happen? What else happened? And correlating these. To get there, services need owners. This is not easy. Like, I think it's fun. I think it's fun, but I don't think it's easy. I think it's important, and I think it's worth doing. I think that it's the biggest high that I've ever gotten on computers, is tracking down those outliers and finding something. It's fantastic. It doesn't mean it always has business value. But increasingly, we also need to think about the tools we're building from the perspective of the software engineers who are using them. And that means, every problem that you're tracking down should be able to be traced back to the line of code, right, that you have control over. There's nothing worse than having all the power and responsibility to fix things but not being able to. There's also nothing worse than being able to but not being able to figure out what to do, right? We have to knit these two back together in our Garden of Eden or whatever. And every pull request should include the question, how will I know when this doesn't work, right? This has to be, our development will be better if it is driven by observability. I feel like, in the same way that our concept of what is prod, right? It's not a true false thing. It is a process of baking, a process of increasing our confidence over time. Nobody should trust code the first time it gets shipped to prod. You have no way of telling what's in that thing. God. But over time, you gain confidence after you've seen it perform in the real world, talking to real services, real data, real users. Back to our analogy about the national electrical grid. There's a lot of value to testing online, but you can never predict what your users are going to do tomorrow. So it's limited, right? Even if you capture all the traffic that happens in a single day and replay it against a copy of production exactly, which I have done, which I love doing. It's the best way to test database changes. You still can't predict what your users are going to try and do tomorrow. It will still surprise you. So we as engineers spend too much time inspecting these elaborately falsified, controlled environments, thinking that that translates into quality in the real world. And it does only to a point. And that point is not as far along as we would like. So I feel like the first phase of DevOps was like about, God, how many years? Years and years of just yelling at ops people to learn to write code, right? Just like, yeah, you must write software. Like, okay. We have, right? Great. Lesson we needed to learn. And for the last couple of years, I feel like the pendulum has really started to shift. And now it's much more about, all right, software engineers, your turn. Right? Your turn to learn how to build operable services. It's your turn to learn how to own services and how to care about quality and how to really understand the impact on your users. And this will make you a better engineer. And our job as operations people is increasingly that of specialists. You know, we're not here to run your systems for you. We're here to run the infrastructure and to help you own your code and your systems in production. And I think that that's the trajectory that we're definitely on. So, in conclusion, watch it run in production, accept no substitute. If you don't know what your system looks like when it's normal, you have no fucking chance debugging down problems when it's not normal. So, tonight we test and prod. And that's basically the end. Oh, one more thing. And you win, like as a reward for all this pain and all this change and all this trauma, you can delete the number of things that paid you by like 90% easy. Just delete them. They are doing more harm than good. They're burning you out. You're using them as a debugging tool. That page bomb of like 500 errors that goes off at 4 a.m. to warn you about some warning in an unconnected system over here. Well, we lean on those because we haven't had the ability to just ask questions and just like in real time slice and dice and like answer these questions quickly and reliably. Once you can, fuck all those paging alerts. The only thing that you need is like errors, latency, request rate, and some top level, end-to-end checks that traverse the code paths that make you money. And maybe repeat that for each service. That's it. That is all that you should ever be paged about. Thank you. You're welcome.